Last class, we learned different karst landforms, both above and below ground, which collectively shape the highway's karst environment. Different karst development stages and development intensity characteristics will directly affect the difficulty of highway construction. Next, let's study the evaluation method of karst development degree together. There are three key indices for evaluating karst development, which are collapse prediction analysis, karst rate of borehole line, and hole penetration rate. First, we look at the first evaluation index, collapse prediction analysis. There are three basic conditions, which are water collapse dynamics, mulch collapse material, karst collapse and storage and transportation conditions. Different basic conditions contain different influencing factors, and the level of factors determines the index score. Finally, the cumulative index score is calculated. According to the table, we can predict and analyze the karst ground collapse. An area with a cumulative index score of 90 or higher is considered as a high risk of collapse. An area with a cumulative index score between 71 and 89 points is deemed to be at risk of collapse. An area with an index score of 70 or below is classified as a low risk of collapse. Next is the second evaluation index, the karst rate of the borehole line. What is the karst rate of the borehole line? This is the karst geomorphology model of Nantyeon Expressway, a school enterprise cooperation project. First, a piece of drilling core sample is taken from the model. We can observe that the upper and lower parts of the drilling core sample are filled with rock and soil, and the middle is filled with pores, which indicates that the karst cave was encountered during the drilling process. So the karst rate of the borehole line refers to the ratio of the length of the pores to the total length of the drilling. That is, the karst rate of the borehole line is equal to the cumulative length of the karst hole on the measurement line, divided by the total length of the measurement line, and then multiplied by 100%. This is a critically important metric. Moving on to the third index, cavity encounter rate, which refers to the probability that we encounter karst holes and dissolved gaps in the process of drilling core samples. That is, the drilling hole rate is equal to the number of holes that encounter karst holes and dissolved gaps on the measuring surface, divided by the total number of holes on the measuring surface, and then multiplied by 100%. According to the above three indexes, the corresponding development degree of karst is the one that meets one of the following conditions. In order to ensure the safety of construction, we follow the evaluation principle of adopt the higher to evaluate the development degree of karst region. The harm is analyzed and the treatment methods are put forward. For example, F. The collapse prediction analysis indicates a low risk of collapse. The karst rate of the borehole line is less than 3%, and the rate of the borehole is greater than 60%. It is judged that the karst in the area is highly developed, according to the principle of prioritizing the highest risk indicators. We have just learned the evaluation method of the degree of karst development together. Next, let's use what we have learned to evaluate the degree of karst development of the Nantyeon Expressway. Please carefully observe the karst model. Calculate what kind of subsidence area does the karst area belong to, the value of karst rate of the borehole line, and cavity encounter rate, and conduct a comprehensive evaluation of the karst area. According to the relevant data shown on the geological model map, the water level in this area can fluctuate under the soil and rock layers. and the actual score is 40. This area is mainly sandy soil. The actual score of 20 points. The model shows that the soil layer thickness is 10 m, and the actual score of this item is 7 points. This area belongs to the typical karst depression landform. The actual score is 15 points. We can see that there are surface and underground karst forms such as funnel, depression, sinkhole, solution trough, stone tooth, and underground river in this area. The actual score of this item is 15 points, and the comprehensive calculation score is 97 points, which can be concluded that this area is vulnerable to collapse. Then calculate the karst rate of the borehole line in this area. At this time, the cumulative length of the karst gap in the measurement line L is 70 m, and the total length of the measurement line H is 200 m. Through calculation, the linear karst rate, K, here is equal to 35%. According to the data, the total number of boreholes is 10, and the core samples with pores are 7. So cavity encounter rate is equal to 7/10 equals 70%. Based on the above data, according to the principle of prioritizing the highest risk indicators, the geological model belongs to the strong development of karst. In this class, we have learned the evaluation method of bridge and tunnel karst, the degree of karst development. Strong karst activities will lead to the collapse of bridge foundations, tunnel collapse, water gusher, and other engineering geological problems. In the next class, we will learn the prevention and control measures of bridge and tunnel karst.